Hello everyone, we have new circuits here. Let us see the circuit. This one, it has an LED, a resistor, and an optocoupler, or sometimes called opto isolator or photocoupler. And this one is has a resistor, LED, and a relay, 6 volts connected to a 6 volt supply, and this one is 5 volt supply connected to a 5 volt supply. What is these two circuits? Let us see the circuit. We have here a relay circuit. This one, a voltage supply 6 volts, a switch, and we have a resistor, LED, and a relay. This is circuit diagram. We computed all the values of the resistor here and some parts here, and this is our previous circuit. And this one is optocoupler circuit on the control side. We have a voltage supply, a switch, then a resistor, LED, a resistor here, and an optocoupler here. This is our new component, optocoupler. Inside the optocoupler is a photodiode and a phototransistor. This is the circuit diagram. So what's the use of this optocoupler and this relay circuit? These two circuits are used to isolate two circuits, or so we can examine each current flows. Let us see the current flows here. At the relay, when the switch is closed, voltage supply is current flows here to coil up the relay to the ground. And then also current flows here, the resistor, the LED, and since the current flows at the coil, inducing a voltage here, producing a magnetic field, the contact moves to the terminal 5 of the normally open closed, and then we have a closed circuit here, also here. These are two closed circuits. We use a resistor here to protect the LED. And then we have two closed circuits here, making the contact to move to terminal 5 of the normally open terminal. In here, the current flows when you close the switch at the resistor to the terminal 1, pin 1 of this optocoupler, making the photodiode inside the optocoupler to emit light, and conducting this phototransistor, making a circuit here, and we have a closed circuit here. We need a resistor here to protect this photodiode inside the optocoupler. Also, there's a current flows here at the resistor and the LED, and to the collector side of this phototransistor, and to the emitter side connected to the ground. This optocoupler is used to isolate circuit, but we're just using one power supply, so just like here, we're using one power supply. These two devices or components are used to isolate circuit. So let us try to find out the values of each resistor here. Finding the value of this R1, which is used to protect the photodiode inside the optocoupler, using the given At the data sheet of the optocoupler, it has a forward current of 50 milliampere at the input and forward voltage of 1.2 volts. Means it has 1.2 volts here, terminal 1, and 50 milliampere forward current. Also, a collector current is 50 milliampere for this optocoupler. I'm using EL817. So calculating the value of the R1 here, we have Kirchhoff's voltage loop using this yellow line. Follow the yellow line when you close the circuit. Voltage supply minus the voltage drop across the resistor 1 minus the voltage drop across the photo diode here, and we get here 3.8 volts. This 1.2 is the forward voltage of this optocoupler. Now using Ohm's law to find the R1, 50 milliampere here is the forward current of this optocoupler. That is the current forward in the optocoupler. And we got this 72 ohms, but I use 500 ohms available resistor. But it's still okay, it's still functioning, still working. And to compute for RD here, using Kirchhoff's voltage loop, voltage supply minus voltage drop here, voltage drop here, voltage drop at the collector emitter at the saturation mode of this transistor is equal to 0. And the voltage collector emitter saturation is 0.1. Data sheet of this EL817. And we get a voltage drop across the RD 2.9 volts. Using Ohm's law here, we know the value of the voltage drop across the resistor, the current, and we get here, we have here 20 milliampere because that is the data sheet of the LED that is given, 20 milliampere. So we get here 142 ohms. I use 1 kilo ohms. That's my available resistor. I just use this one for much bigger protection. We have the parts here, 500 ohms, 1 kilo ohms, LED, EL817, 5 volts, and perk board. So what's the difference between the two? When the current flows here at the pin 1 to the anode and to the cathode, the photodiode is emitting this light, making the transistor here, the phototransistor, to activate this phototransistor here by using this photodiode. In here, the coil is activated and it produces a magnetic field, moving the contact to the terminal 4, closing the circuit here, making the LED on. Just like here, when the current moves here, the photodiode is emitting light, activating the phototransistor, and then the current moves here, conducting the transistor, activating it, making the LED turn on to the ground. A closed circuit here because this one is this has no electrical connection, only the light making this transistor to activate. And this one, it has no electrical connection, only the magnetic field. So in here, since there's no electrical connection, you're using this photodiode. In here, you are using just a magnetic field, moving the contact to terminal 4. So we can have a circuit here, closed circuit here, and also closed circuit here. Just like here, we have closed circuit here and we have a closed circuit here. Both are happening at the same time. When the current flows into the coil, contact moves here, making a closed circuit here, conducting an LED, making LED to turn on. Just like here, when the current moves here, it will turn on the transistor. At the same time, it will close the circuit conducting the transistor and activates it, and we have a closed circuit. So both have the same characteristic here. One loop here controlling this flow, and also here controlling the flow. The other loop is here to the LED, to the terminal of the relay, and to the ground, just like here. So these are the two circuits, and I have this one, our circuit diagram, and we have this layout. So these two circuits has similarities. They are both used to control two circuits, but in our design it's just controlling one circuit here. We're using only one power supply, 6 volts and 5 volts here. So thank you for watching the video, and